Hello, everyone. Thank you so much for coming to this talk. My name is Dako Wang. It's my great pleasure to represent our research team to present this CSCW paper on group chat ecology in enterprise instant messaging, how employees collaborate through multi-user chat channels on Slack. We aim to update the existing literature, for example, this classic one on interaction and outeraction, which was published by Borninardi, Steve Whitaker, and Aaron Breitner in 2000. Back then, they were studying some very preliminary instant messaging systems and how the enterprise contexts were using these systems. They found, for example, people are using these instant messaging systems for the following four use cases. They may ask short questions and ask for classifications. They may also use instant messaging to coordinate and schedule meetings. Our research question is, are these findings still valid? Is there any updated knowledge that we should add? The reason why we want to update this knowledge is because lately there are more and more machine learning researchers are relying on the work that we presented from 2 decades ago to develop and build their machine learning algorithms and AI systems. For example, these 2 NLP research papers published in 2018 and 2019, they use some hypothesis which sounds not very accurate in today's setting. They assume that a group chat channel should not have more than 10 concurrent conversation threads at the same time. Also, they have an assumption that a conversation thread should always have more than 10 messages within a single thread. With these assumptions, they then build on top of these premise and then develop their own algorithms. For example, one particular algorithm could be to automatically detect the thread. There's one sentence and which thread this sentence belongs to. That's called a sentence. That's called thread detection algorithm. But we argue if the fundamental assumption and the understanding of how humans are using these instant messaging systems are inaccurate, then the algorithm building on top of these hypotheses are also likely to be inaccurate. With that motivation, we ask this. We know very little about how today's people participate in group chat inside a real-world organization. Within this work, we focus on this particular study site in which we have a total of 4,300 group chat channels who are all using Slack within a research and development department in a multinational IT company. In total, we also have 117 product teams data. So these 117 teams data is a subset of those 4,300 group chat channels. We know these teams' composition and also some metrics about this team's performance. Our research method is a mixed method. We first randomly sampled 100 group chat channels and then conducted qualitative coding to understand the context, the user behaviors, and also trying to cluster them into some categories. Eventually, we developed a taxonomy of 9 categories. The second method is that we are hoping to train a machine learning algorithm so that the algorithm could learn from our coding behavior and then automatically clustering any unlabeled Slack channels. There are in total 21 features that we used in the machine learning algorithm. These are all related to the meta information, which means we don't need to look at the actual content to preserve privacy. What we found here, I will highlight only 2 parts of the data. So for the first data, we are looking at the 9 categories of group chat channels. These are very distinctive from each other. For example, 32 out of the 100 Slack channels that we qualitatively annotated belong to this project category, which means people are primarily using these channels to discuss topics related to particular projects. When you look at some other channels, there's only a chatbot posting message, and all the other users are only subscribing to those messages. So these kind of channels are primarily used for some IT service or particular systems maintenance log for monitoring purpose. There are also various other distinctive characteristics for the other channels. The second part of the result is related to these 21 features, as I mentioned earlier. Here in this table, I'm only listing these 21 features as the rows, and then columns is only the 3 categories of the group chats. So as you can see, for example, if we look at on this particular characteristic, this measure of average turn per thread, which counts how many messages in a thread, you can clearly see that in different categories of these channels, people's behavior are quite different, which means, for example, for IT support channel, on average, each thread will have 4 turns, which means 8 messages. But for a project-based channel, each thread will normally have 2 turns, which means 4 messages exchanged. In summary, these are showing very distinct differences between different channels, and these are inconsistent with what the related work have already shown from the 2000 paper posted by Borninardi. That means in the future, when machine learning and researchers and the system developers are trying to develop these kind of algorithms and building systems to support human, we should really take into account this updated knowledge. With that, I would like to conclude my talk. There are more findings and discussions reporting the paper. Thank you.